you so much.
Have a nice talk.
No, wait a moment. I have something for you.
Ah, okay.
This one is for you, just for thank you for the coffee.
Okay. Thank you all. Have a nice talk, Luca.
Okay. So I try to help you to don't sleep for the next 40 minutes. And let's start from here. So if you don't know me, I'm Luca Del Puppo. I'm a senior software developer in Nearform and JavaScript and TypeScript lover. I love running, hiking, but when I have a free time, I try to run my YouTube channel and write some tech posts for tech people. By the way, let's start from here. Today, I don't talk about Rust. So if you are here to talk about Rust, apologies, this is not the right talk. I know Luciano already did a great workshop and a great talk. So if the idea was to talk about Rust, the door is there. Second, why this talk? So we are developer and we love to follow the hype, and in this moment, Rust is on the top of the hype. And we love to learn it and how we can test our skill. Basically, we love to put it in production because the best way to test it is in production. But basically, do we really need to rewrite here of JavaScript code in Rust? This is the real question because basically what happens is you go to the business and you want to have time to rewrite something just for, basically it's for fun, but we say it's for better performance. We have a better application then that basically is the same as, but written in Rust and not in JavaScript. By the way, if you want to rewrite something in Rust, this means money. Time is money that your company needs to invest in your job to have the result at the end. The real problem is that when you ask money, you have probably to talk with the business. And there is just one thing so that they know when they talk with you about money. Basically, okay, you ask me an amount of money for rewrite this. The investment is okay, but how we increase the revenue doing this work? Basically, if the result is the same, the answer probably is, I don't want to spend time to do this. If the result is 3 times of the amount that they have to invest, probably they start to thinking about that, and if the amount of money start to increase, probably they say, yes, we can do it. We can start yesterday if you want also. But honestly speaking, if you have to rewrite something, it's a waste of money in the majority of the case. So if you want to rewrite something in Rust, I give you another question. Have you already checked your JavaScript code is already at the top performance that you can have for your application? If the answer is yes, okay, probably, and you have the need, okay, because sometimes the problem is, do you really have the need? Moving to Rust can help you, but it's not true, depend. But probably in the majority of the case, you haven't checked your JavaScript code. It's 10 years of JavaScript code written bad. And the result is that at the end, it's not an investment that you have to do. The better investment that you can do is check your JavaScript code and improve it. Basically, it's enough in the majority of the case to have a better performance and also a better experience for your user. I want to be clear. I'm not saying that rewrite in Rust is wrong, but it's real the thing that you need, because maybe you have a simple microservices that need to improve the performance. Maybe it's okay to rewrite it in Rust. But sometimes, in the majority of the case, the problem is that we are developer and we want to try it because we love to follow the hype. So basically, is the real value for your business? In the 90% of the use case, the answer is no. In the 90% of the use case, probably if you check your JavaScript code, you can achieve your performance without any problem, and probably you can save money for your business and go to your manager at the end of the year and say, okay, this year we save 10, 50K of euro just to not rewrite our application. Can you give me a review of my salary, please? This sometimes can help. And in the 90% of the case, remember, your fucking JavaScript code is still blocking your main thread. And this is why you have to review your JavaScript code. So before we get started, what we will see today, some JavaScript syntax that basically the people, I don't know, they love to use it, and basically are slower than another. Some JavaScript syntax that have different performance based on the node version, or how to not kill your main thread because you are waiting to do something in your thread. And if you need to work with performance, I give you 3 points that you have to follow. Basically, this 3-pointer works very well with all the languages. It's not just for JavaScript, okay? If you need to review a code base with many of here, probably there are a lot of layers of JavaScript and a lot of stuff that are there just because no one won't touch them, okay? Okay, it's there and it's work. But sometimes there are some death code that you can remove, and maybe they already improve enough your application for your result. And at the end, remember that if you can do nothing, when you run your JavaScript code, if you do nothing, it's faster than do something every time. If you can offload something to someone else, for instance, there are a lot of people that love to load all the table in the server and then filter the data inside of Node. If you can do it in the database, do it in the database. Database is there for help you and not to kill your main thread. So if you can offload the problem, offload the problem. And if you can do it later, so if there is a piece of the code that you can do it in the second moment, do it in the second moment. But probably you have some piece of the code that help you to say, okay, maybe I have to do this just if I am in a specific case. But the people love to do sometimes the stuff before. In this case, if you move this piece of code later, probably you don't have to run it. You run it. And if the answer is yes for one of these questions, you are lucky and probably you have already found the solution. Otherwise, you have to take care of your JavaScript code. So now it's time to jump in the code. Just to understand, is it okay the font also in the no or yes? Now it's better? Perfect. Okay, the first example is pretty stupid, but I found it in the previous work, and I spent 1 day to understand what was the problem. Do you know the scope in JavaScript? Okay, if you don't know it, you can do a lot of problem for your teammates in the future. Here, there is a simple, the example here is pretty simple, was a bit different in my code, but basically the idea is the same. This is a function. The function basically is to return a class with a method that is a say hello. That basically is a simple class with the name and return, in this case, hello and the name that you have passed. In this case, the class is declared inside of the function. Here, the real problem is that JavaScript needs to create this class every time you go inside of the function. This means that if you have this code and you call it just one, it's not a real problem. But if you call this function, I don't know, 1,000 or 2,000 or 1 million of time, probably you are wasting a lot of time to recreate the class on each iteration. Now, how we can fix this? It's pretty simple. Basically, the class, you can move it outside of the function. Here, JavaScript need to create the class just one, and then you can use exactly here the same class and call it just the declaration of your object. It's stupid, right? But one guy told me, yes, but that time he told me, I already have the class with the same name. I cannot declare another class with the same name. Yes, fuck, use another name. It's not a problem in this case. Yes, but I spent 1 day for this problem. Then we can check the result here in the terminal. Okay, I don't know if in the handoff is okay the font, also in the terminal. Oh, it's better? Okay. Basically, this is a benchmark tooling called Mitata that you can use to check to make a benchmark for your function in this case. Basically, the summary here is I basically call the same function for 10,000 times. And basically, the function without the class inside is 166 times faster than the function with the class inside. As you can imagine, we are losing a lot of time just to recreate the code, the class on each iteration. Yes, it's pretty stupid, but I understand that it's not the same for all the JavaScript developer. Now, after this simple example, it's time to go to the array iteration. Now, I don't know why, when especially the React developer love to use the reduce method for create a new object, okay? And after the hype of the immutability of Redux, they start to use the reduce in a strange way and this strange way is the best way to kill your application. Basically, here is a list of people, and what we have to do is we create another list with just the name and the surname of the person. In this case, the problem is the concat. They love to create the instance of the array here, and for each iteration of the reduce, they basically create another array. This means that for each iteration, they are creating another array using the concat and another array to push the new element inside of the contact. Here, we are losing time for two new declarations. The declaration of the new array result of the contact and the declaration of the array here of the new element to push in the list. I don't know why the people love to do, especially in the front-end side, do this kind of stuff. Basically, if you are creating a new array, it's not required to use a concat and make the reducer immutable for each iteration, okay? Basically, you are creating your array in this moment, so you can push whatever you want and maybe freeze it after this after the result. What happens is if, for instance, we are using the push instead of the concat. Basically, it's the same array here. We just need to push a new element inside of the list. This, at the end, basically helps us to create the array just one time, okay, at the beginning, and push the element on each iteration. As we see later, basically, this it's faster than the previous example. But the people forgot that using the reduce, there is a call for calling the reduce function. This means that JavaScript needs to go to the stack, create the new function, and do the work for the reduce. How we can improve again our iteration of the list? Basically, sometimes this solution is enough for the performance that you have to achieve. If you have to be more faster, you can improve a bit using the for of. Basically here, we can use the const result to have the result of our iteration. And using the for of, we are improving, again, the performance of our iteration. The result is pretty the same at the end, but a bit faster. But there is another problem. How many of you know why, how the for of loop works? Okay, not so much. Basically, what happens if you have a for of loop? Basically, to iterate a list using the for of means that your collection need to implement the iterator pattern. The iterator pattern is just another object that returns an object with one method called next that you have to call to get the next element of the loop. Okay? As you can imagine, calling this method is time that we have to spend in the heap and the memory to get the result. And basically, the next return another object with the value or done. If done is true, basically the for of is completed. Otherwise, basically you have the next element in the value. How we can improve again this solution? The best loop that you can have for achieve the best performance in JavaScript is the for, the simple for. In this way, if you have problem using the for and this solution, probably you have to move in another language, okay? Or you can move, or you can also do other stuff depending on the case. In this case, just a quick note, there is the length, I extract the length before the for. This stupid extraction help you to have around 5% of improvement of your loop. Why? Because you don't have to jump in the people.length for each iteration. Seems stupid, but you have to start to think like the machine to bring the best performance for your application. And basically here, using the simple for, we can get, using the index, the element, and at the end, push the element in the list. There is also here, yes, the benchmark just to help you to understand the problem. Node source. Okay. As we can see, at the end, the simple for is 2 times faster than the for of. That and is 2.5 faster of the reduce with the push, and is 404 times faster than the concact. So basically, just using the right syntax, we can achieve a completely different result. Now I run it just in 10,000 elements. Sometimes, in my cases, we need to run this for in 1 million elements, and as you can imagine, 2 times is a lot of time at the end. Okay, pretty simple. Now the next element. How many of you love the delete operator in JavaScript? Why? Why? Okay. Just to let you know what happens when you use the delete operator. This is a simple loop, okay? I don't remember the size. And basically, for each loop, for each iteration, I create a new person, and then basically I remove the birth year from the class. What happened here under the hood? When you create a class, basically JavaScript V8 and the end create a shape for your object. The shape means that you have a name, a surname, and a birth year. If you want to delete a property, what happens is that V8 need to recreate the shape of your object. So basically, need to take your object, remove the birth date here, the birthday here, and create the new shape for your new object. This means, as you can imagine, a lot of time that you have to waste just for delete a property. How we can improve it? Okay, it's pretty simple. If you need to remove just the birthday, remap all the object without the birthday. I don't know why, you are probably asking, but basically under the hood, they don't need to work with the shape, but basically they create a new instance with this property, and the result is faster than delete and recreate the shape of your object in this case. So basically the result is pretty simple and pretty stupid. There are a lot of elements here. I don't remember how many. We have to wait. Come on. Someone want to talk something crazy in the meantime? Okay, we have the result. Okay. As you can see, the create new object, when you have to map again, the object is 4.5 faster than delete. And in this case, we are talking about 10 million elements. Okay, it's a big. At the end, it's a big collection. But obviously, if you have 10 elements, probably you don't have to handle this kind of problem, and you don't have to spend time to improve it. 10 elements is something that probably is 10 milliseconds. Nothing is a problem. If you start to have data inside of the collection, probably pay attention in the detail can help you the call of your manager. And you can go to ask the money at the end of the year. Okay. It's strange to see what happened under the hood, but the clone. Basically, here you have to make a decision. Cloning JavaScript can be done in two different ways, okay? The shallow clone and the deep clone. Sometimes you must have the deep clone, and basically you cannot handle in so many ways. The best probably method is the structural clone, already built in the JavaScript ecosystem. But sometimes you don't really need the structural clone. So how we can handle it without any problem? The first example here is the spread operator. I think everyone knows the spread operator. The real problem is that we are creating just a new reference of the object, and basically only the first level of our property are cloned. The rest of the depth of your object is still the same. So if you have an array inside of a child element, basically is the same. But using the spread operator, maybe you can improve a structural clone. Here is the example. You can have a simple spread operator, or you can use the object assign with the square bracket. In this case, you can create the object assign is a simple method exposed by JavaScript. So you can create a new object. Basically, this one is the new object, and you are saying, okay, copy this object inside of this one, and you have a new shallow copy of the object without losing too much time, like using the structural clone. Obviously, if you need to have a simple shallow copy, it's okay. If you have to handle the structural clone, this is the real method, and you have to wait. You don't have many other solutions to improve this copy. At the end, so here we have the benchmark if you want. Sorry. Basically, the spread operator is 2 times faster than the object assign and 74 times faster than the structural clone. So also here, depend on the case. There is not the perfect solution for each time, but if you need to improve the performance and you can move from the structural clone to the spread operator, probably 70% of your time is better than nothing at the end. And here, I don't remember the element. There is no The element are, I don't remember the number, yep, but a lot of element. Okay, now it's time to moving to this one. Set or array. Sometimes we have an array or something else, and we need just to check if the element is inside of a collection. There is different way to do it. You can use the find, the filter, the sum, if you have an array, or you can use the set. But which one is the best one in terms of performance? The Fox says, okay, build array is a simple function to build the array, nothing else, and build set is the simple function to build the set, okay? The first example here is with the sum. The sum basically is a method that accepts a callback that allow you to find for something inside of the array. In this case, if the element is 0 or 1, I return true. The real problem is here is that if you have a big list, okay, and the element is at the end of the list, you have to iterate at the end of the list to understand where is the element. An image, you have to you have the sum inside of a loop. Basically, for each iteration, you are looping again just to check if the element is inside of the array. As you can imagine, this one is one of the worst way to check if the element is inside of the array. It's better to use the includes if you are in the array side. In this case, you just need to send the element that you want to find, and under the hood, V8 or the engine do it for you. It's completely different, the algorithm inside, and it's faster, more faster than the sum. But if you use the hash, you can have the best performance possible. Basically, here, using the has, the set is a collection built just for that case, okay? The has is faster enough to probably resolve all your problem. And it's simple to use, but imagine you can also have a list in the array. You just need to convert this list inside of before calling the loop, and on each iteration of the loop, if you use the set, you can improve the performance of your application without any problem. Just to benchmark in the result, also here, clear. Okay, let me open it again. Okay, as you can see, the set is 1.70 times faster than the includes. So basically, sometimes you don't need to move from a set if you have an include. Depend also on the list. Now the list is pretty small because there are just 10,000 elements. But as you can see, the result with the sum is 9,500, okay, times slower than the set. As you can imagine, choose the right structure help also your application to be fast. And sometimes it's pretty stupid if you know the solution, but think on how the machine works. Sometimes it's not helpful for our mind. By the way, go ahead and talking about map and object. How many of you use an object as a map? How many of you use the map as a map? Oh, okay. How many of you use a map as an object? Okay. By the way, sometimes we need to use an object or a map just to have a key-value pair, okay? Pretty simple. But which one is the faster in case we need to work with performance? Now the answer is depends, okay? And depends on what? The first example is pretty simple. Basically, I'm building a new object where the size, the key, basically in this case is the number, is always the same type in all the keys. So basically, all the keys are numbered in this case. And the value is the number, but it's not important in this case. Now, here is the same with the map. The key is a number, and the value in this case is the same number. We have to check which one is faster to check if the element is inside of the list. We can use for the object the has_home property, okay, or we can use the has for the map. Now it's time to try to win this one. So now we can start to bet. Which one is the faster? And Matteo Dazzi, you cannot answer. No, also you. And don't be shy. It's just an M, but you can also use it in the call with your teammates. Object. Someone else want to? Map. Map? Okay. Someone else want to try? Okay. You say object. Let's see. And the winner is object, so you win this one. Someone know why? Basically, if the key are the same, object is faster. As is it implemented, the result is this one. But for all the people that answer mapper, remember that there is another example here. If the keys are different, so basically in this case sometimes it's a number and sometimes it's a string, the result is opposite. And this is the benchmark. Under the hood, basically, okay, the map is faster in this case. So also understand which are the keys for your scenario, help you to improve the performance of your application. Yes, now we are talking about 1.66, nothing special, but if you have to do it in 1 million elements, it's different. You are preventing that the main thread is stuck to iterate over the map or what you are doing, basically. Okay, pretty simple. I have too much screen here. Okay, this one is pretty fast. How many of you love the hat syntax? How many of you use it? In reality, I can skip this part. You are already perfect in this case. But basically, just to let you know, if you want to use the hat is a method for the array that allows you to keep the element in this index at the end. The hat is slower than the simple access by index. Because basically, if you think about the hat is a function. You have to call the function, create all the kind of stuff in the stack, handle it, and basically, this is why it's less faster. Let me do the example. And as you can see, is 1.5 slower. But now it's time to start to understand how not to kill our main thread. Here is a stupid example. There is a Fastify server that basically have different routes to handle the Fibonacci number. How many of you love Express? Why? You have to rewrite your application using Fastify. I'm sorry. Okay, just to let you know, the application is stupid. There is a Fastify server, and there is an interval that help us to understand if the main thread is stuck or not. Okay. Then this is the first implementation of Fibonacci. Is the beautiful recursion with the function, and we will see what will happen. Here I can run my application. And I can open another tab here. As you can see now, the main thread works as expected. Every 500 milliseconds, we have the result. What happens if I call the Fibonacci with the 40 number? As you can see, now we have a moment where we have the answer at 800 milliseconds. If I call it with a 50, now the main thread is stuck. And people, in the majority of the case, say, oh, no worry, I have the user that have to wait. Yep, but if you have 3,000 users, you have 3,000 users stuck to wait one user, because your server cannot answer to the other. How can we improve it? Let me kill, because it takes too much time. OK. How we can improve it? We can move the elaboration in the worker. So this means that we have another process that handles the Fibonacci and return the result when it's completed. If you already follow the workshop this morning, basically it's the same that you already seen. But at the end, here, I create a worker. The worker is a JavaScript file, pretty simple. And basically, you can listen to the message. The message is the event that you receive when the worker completed the job, or you can listen to the error. And when you receive the error, in this case, there is a map that have the request ID, and in the request ID, you have the resolver, and the resolver basically return the result. The implementation here is a bit difficult to read, but basically we have a request ID here. We have a promise that waits for the work in the worker. Basically, we set the resolver here in the map, and we call the post message with the request ID and the number. The worker is pretty stupid in this case. Is another simple JavaScript file with the on message. So basically, when you receive a message, here we have the number and the request ID. And basically, at the end, you can post the message with the request ID and the result. So using the request ID, you know which one is the correct promise to call to return the result. And here, you have the result of the Fibonacci. At the end, we can call again this part. Using worker, we can use the 50. Now, as we can see, we don't have the result, but the main thread is not stuck. So basically, you are handling the request, but you can also handle the other request that maybe the other 3,000 users ask to your web server. Now, let me do this so we can see that it works, probably. I don't remember which one is, probably 30 is enough. No, it's, oh no, sorry, I have to kill it because I have the worker stuck with it. But if I put 20, the result is here. And the main thread continues to work without any problem. Now, this solution works, but there are a lot of code that we have to write. How we can simplify it? We can use Piscina. Piscina is a NPM library that Matteo Collina already built for us and help us to have a simple implementation of the worker. In this case, I already registered the Fastify Piscina plugin, and basically I say, okay, in the worker dash Piscina, I have the implementation of this worker. The worker is pretty stupid in this case because basically is a simple import of the Fibonacci, and I return the default implementation of Fibonacci. And the result in the Fastify application is this one. I can call server.runTask with the number, and that's it. Now, if I call this with Piscina, we have the result, and also as you can see, the main thread is not stuck. But I want to give you the last feedback. In reality, sometimes we don't need to use the recursion. The recursion is one of the worst things that you can implement in your application, because you have to work with the stack and remember how to go back. What happens if the Fibonacci implementation is just a simple JavaScript, like in this case? As you can see here, there is no recursion, no problem, just a while, and exactly 2 variables. The implementation here is this one, Fibonacci fast, and call is exactly the method. At the end, if I call Fibonacci fast with the number 1000, I already get the result without any problem, in less than probably 1 millisecond. It's stupid? No. Basically, you prevent to do a lot of stuff in the stack in the memory. If you can improve your code, like in this case, probably you can achieve also your performance improvement in your application. Then you are probably asking how I can benchmark this kind of stuff. There is a fantastic tool called AutoCannon that can help you to basically call the request many times. And in here form, we also created AutoCannon UI that basically is a implementation in the UI. Let me go here. Okay. In a UI implementation of the AutoCannon. You can do localhost Fibonacci with 30 and run the test. Now for you, this UI start to call the server many times, and you can see the result in the bottom here. You have the number of requests and stuff like this. But probably you are asking, I want to benchmark it. So basically you can also call, for instance, the fast, call the run test. You have to wait another 10 seconds in this case. You can also, if you want, set up different kind of stuff. And at the end, when you have the result, you can compare them. And at the end, we can see that the implementation with the recursion is 100% slower than the other. The throughput is completely different, and stuff like this. This helps you to understand if your work in the improvement it's working or not. Now I already completed the time, so I give you the last example for homework, and you can find it in the here. And we can go to the slide to complete the talk. Conclusion. So if you have to work with performance, try to find where you are killing your main thread and fix it. There are cases where probably you are not able to improve again your situation, and probably move in another language can be the result. But before, try to understand if it's possible to improve your JavaScript code, because rewriting everything is a lot of time. Then, if you can push outside of the main thread the stuff, it's fantastic, because basically you are handling it in another way. Use the log. I don't know, some of my teammates don't love it, but if you have log in your application, it's easiest to find the problem in your application. And remember, if you want to work with performance, you can bring the clean code book and use it for raise your monitor or put it in the bin, because this is the only solution when you need to work with performance. And the last things, when you work with performance, remember that programs don't run in mathematical abstraction, but run in the hardware. And you need to know how the hardware works to improve your code. After that, I completed the presentation. This is the QR code for the presentation if you want. I give you it also to the Codemotion team. Here is the QR code for the code. So you have also the homework here if you want. And these are my contacts. Twitter and LinkedIn are free. So if you want to chat with me, I'm here till 6. Then you can grab me a message without any problem. If you want to follow me in YouTube or DevTO, these are the account. I remember that in Nearform we are hiring if you want. And thank you so much and hope you enjoy it.